Hi all the students of Narayana 9th standard. Today here I am in front of you all to discuss assignment number 36, which is from the topic center of mass and collisions. Let us go with first question which is given in this assignment 36. So the first question which is given for you all in the assignment 36 is two uniform rods A and B of length 5 meters and 3 meters are placed end of to a position to end if their linear densities are 3 kg per meter and 2 kg per meter, the position of their center of mass from their interfaces. So if you want to find the center of mass of this particular thing, then you would go in this particular manner. Like you can go with, let us take the first rod which is having of more density as a little bigger one. This is the first rod which is having 3 kg per meter cube as a density, and let us join this rod with another end of the rod, that is another rod. You take it with little bit smaller than this, because this is a smaller rod and that this is a bigger rod and that is a smaller rod. And now let us take this rod is having some mass m1 and this rod is having some mass m2. Now we don't know what is the mass, we have to find out. Now what is the thing which they gave you? They gave you the length of the first rod is given, which is 5 meters, and they also gave you the length of the second mass, density of the body of a rod is length is given, length is 3 meters. Now you only know density over here. Let us write down the density. This one is rho 1. Density of this first one is given as 3 kg per meter, and this is given as density 2, which is 2 kg per meter. Now from there I think we can find m1 and m2, because m1 is nothing but density 1 into L1. So density 1 into L1 is going to give you 3 into 5, which is 15 kg, which is 15 kg. And again m2 is going to come up like density 2 into L2, which is density 2 is 2 kg per meter and length is 3. 2 3s are 6 kg you are going to get. Now we will observe the center of masses. The center of mass is nothing but it is going to be somewhat around half of the length. So let us take that length. Actually the length is 3 meters, and if you check out the center of mass, it is going to be somewhat around here. I'll draw it with blue. So let us take that blue. Let us think the center of mass of this one is over here, center of mass of this one is over here. The first rod center of mass is at this particular position, second rod center of mass is located at that particular position. Let us think the distance from here to here is x1 and distance from here to here is x2. Okay, so x1 is how much? x1 is equals to L1 by 2. Now what is L1? L1 is 5. That means I'll take it as 5 by 2. 5 by 2. And this is, if you draw a Cartesian coordinate, this is minus x, this is minus x, and this is plus x. That is positive. So now what happens is I will take this as x. x1 is equals to 5 by 2 meters and x2 is equals to 3 by 2 meters, because the length is given 5 by 2 and 3 by 2. So x2 is 3 by 2. From here to here the length, this one is from here to here. Okay, so this is the second rod. Now let me draw that little clearly. Let us take this first rod which is of little denser, or which is having more mass as a bigger rod, and which is having less mass as a smaller rod. Okay, now if you observe clearly the lengths of these two rods, the length of this first rod is given as 5 meter. 5 meter, this is the length, 5 meter. Now I don't want the length of the complete rod, I only want the length of the center of mass of that particular one. Center of mass is going to, let us think the center of mass is over here. In this rod, let us take the center of mass distance is x1, which is going to be x1 is equals to the total 5 by 2. So this x1 is 5 by 2. Now we will take the center of mass of this one. This one is x2, which is complete length is 3 and the half of the length is 3 by 2. So x2 is 3 by 2. Okay. Now let us find out this center of mass from their intraphase. Center of mass from their intraphase. Intraphase is nothing but connecting to one another. After connecting these two, where would the center of mass be located? That is your position. So now let us take the center of mass of this particular thing. So the center of mass is going to be considered in x component way. We will take m1 x1 plus m2 x2 by m1 plus m2. Now what is that x1 given? x1 is given as 5 by 2. So m1 is given as 15. So 15 into 5 by 2 plus m2 is how much? m2 is 6. So 6 into x2 is 3 by 2. 3 by 2 by m1 is 15 plus 6. 15 plus 6 is 21, right? I'll write it as 21, yeah. And one more thing, here x I'm going to take it as minus x. x1 is going to be considered as minus x because this x1 I would like to take it as minus x, because if you consider this particular thing, you observe this. Now when you are drawing it in this form, this is positive x and this is a negative x, right? So I will like to write 5 by 2, I would like to write 5 by 2 as minus 5 by 2, minus 5 by 2. Right? So now if we are considering this 15 plus 6 is going to be 21, and here 15 into 5 is 75 by 2, minus 75 by 2, minus 75 by 2, and now 18 by 2. This is 18 by 2. So what happens over here, if you try to find out, LCM would be 2 and minus 75 plus 18 by 21, right? So what you would like to do, by 1 you write down, and from here what you will be doing is you just reciprocal it. You would like to get here you will get minus 57, right? This is minus 57, minus 57, and you reciprocal it, you will get into 1 by 21. So now how much you will be getting? 3 19s are, right? 3 19s are, and this is 3 7s are 14, minus 19 by 14, right? This is minus 19, 7 to the 14, right? So we would like to write, how much is the answer? Minus 19 by 7 is your answer. Sorry, 7 to the 14 by 14, minus 19 by 14 meters. Yeah, that is center of mass, minus 17 by 14 meters. Center of mass has been given when you join two rods together each other. One is of mass 3 kg, another one is mass of 15 kg mass and 6 kg mass. If you combine them or interface them, you are going to get the center of mass displaced with minus 19 by 14 m. So from which side you are considering is on the side of the heavier rod. From this side to the center of mass you are measuring. The center of mass is measured from this side to this side. That means the larger rod side to this, where the center of mass is there. So towards the positive x-axis you are measuring. So then it is option 1, 19 by 4 19 by 14 meters on the side of the heavier rod. On the side of the heavier rod. From the side of the heavier rod, you are measuring your center of mass, which is option 1. Hope this is helpful. Let us get into the next question, and we'll get into the next question. Hope this is helpful. So this question, when you consider this question, what happens over here in this question? They gave you a rod which is of some length L, right? A thin uniform rod is given of length L, and it is bent. At what angle it is bent? It is bent at an angle theta, and its midpoint as shown in the figure. Okay, the midpoint is here. At that particular midpoint, they bend it. You have a rod and they bend it. Now when they bend it, it just got, how much did they bend? They bend theta angle. And now its midpoint as shown in the figure, the distance of center of mass forms the midpoint is. Center of mass distance, how much it is going to be formed, they are asking you. When you consider this complete length is equals to L, complete length is taken as L, then after breaking it, what happens is, after breaking it, this part is going to be L by 2. I just broke it into half, right? So L by 2, and this length is going to be L by 2, right? Now let us consider this first piece. First piece, center of mass will be in middle. This is the point where that center of mass is going to be there. Now the center of mass of the first piece, the length is going to be considered as L by 2 by 2. L by 2 by 2. L by 2 by 2 is going to give you L by 4, the small part. From the center of mass of the first piece to that end is called as L by 4. And again this length from the center of for the center of mass from this edge to the center of mass is L by 4. This one is L by 4 and that one is L by 4. Now what happens? You just take a horizontal line from that particular side. Just take a horizontal line. Let us take that it is x, horizontal line. The angle from here to here, let us take from where to where? From here to here. From that x, from the horizontal to this side. Let us take that angle, because angle is also getting into half. So it will be taken as theta by 2. And that side also angle is taken into half. Let us take this thing also as theta by 2. Theta by 2 plus theta by 2 is going to be theta. Now how much you are going to get? So you got theta by 2 as your angle over here. Now I want this another side. Now which is the best option to use? The best option to use is cos theta, because you have an horizontal angle measured from the horizontal line which is x. So cos theta, if you consider that this side is x, let us take that side is x. Now cos theta is nothing but adjacent side by so theta is theta by 2 over here, adjacent side by the hypotenuse side which is L by 4, right? Now what I want x, I want x value. If I want x value, so my x value is going to be equal to, from this question, L by 4 is getting divided over here. I'll send it that side, it's going to get multiplied. So L by 4 into cos theta by 2. L by 4 into cos theta by 2. So my x value is this one. So what is the answer over here? L by 2 cos theta by 2, which is option? No, it's L by 4. L by 4 side, L by 4. Yeah, option 3. Your answer is option 3. Right? Let us go for next question. I hope this is helpful. Now, getting into the next question. Now, this is your next question. Now, coming to your third question, the mass of a uniform ladder of length 5 meter is 20 kg. Here they gave you, I'll take down the given data. Given data is given as m1. Now mass is given 20 kgs. I'll write down mass is equals to 20 kg. Okay, and a person of mass 60 kg stands on the ladder at a height of 2 meters from the bottom the position of center of mass of the ladder and the man from the bottom early is. Now when you want to find this, you take down the M1 is 20 kg and L1 is nothing but 5 meters. Which is the mass of the ladder? Mass of a uniform ladder is 20 kg and the length of the ladder is 5 meters. A person of mass 60 kg is standing on the ladder. He is standing on the ladder at a height of 2 meters from the bottom. See, actually the ladder is 5 meters. On top of the ladder he is standing again. He is standing at the height of 2 meters from the bottom. That means 5 meters ladder. Let us think this is totally 5 meters ladder, but he is only standing at the height of 2 meters. There he is standing. He is standing here. Here he is standing. Okay, from the bottom. From the bottom. The position of center of mass of the ladder and the man is from the bottom is. They want the center of mass of this situation. Anyway, you people are aware about that center of mass, how to do and all. So that center of mass will take M1 as the ladder's mass and M2 as the man's mass, which is 60 kg, and L2 is nothing but 2 meters. 2 meters. Now if you want to find x center of mass, because you can consider it as a horizontal line, so x or y, whatever it is, you take m1 x1 plus m2 x2 by m1 plus m2. Now what is m1 over here? m1 is 20, x1 is how much? x1 is 5 plus 60 into L2 is 2 by 20 plus 60. 20 plus 60. So you will be getting 80 top 100 plus 120, which is nothing but 220, right? 100 plus 120 is 220. 0 0 gets cancelled. 2 4s are 8, 2 11s are. So 11 by 4 you would be getting around somewhat 2.125 meters. You will be getting somewhat around 2.125 meters. So the center of mass from the bottom of the man is nothing but 2.125. Bottom of the ladder is 2.125 meters. So hope this is helpful for you, and let us meet in the next assignment. Until then, bye.